Hey everybody, this is going to be um, the final video in Module 7. So I'm going to talk a little about how you program a differences in differences estimation process. So the first thing I'm going to do is I'm just going to load up some packages here. So Stargazer, so we can view our regression results, and Scales, so we can make some nice little plots. So I made up a setting, but I wanted to kind of talk about um, the differences in differences estimation and how to do it and come up with an example. So we just talked about tutoring. We had talked about fires in cities and how these things work. So I'm going to talk a little bit more about like a typical economics example. So something I just came up with, this is in no way true, but suppose Texas legalizes the death penalty in 2012. So as economists, we want to understand, is this death penalty, if you murder someone, is this death penalty a crime deterrent? So maybe you're not planning to murder somebody and then you get death penalty, but maybe it could be the case that you go to rob a bank and then things go haywire and you end up using a gun and then that gets you the death penalty, right? So this should still deter crime in theory. But let's see, like, we have data, we can test it, we can see if this is actually happening. So we're going to collect data on crime, unemployment, and that's it right now. And then we'll talk a little bit more about how we're going to use the data. But from 20 counties on the border of Texas and Oklahoma. Again, this is all fake data. I'm going to generate all of it, but I'm just going to make a little bit of a map here so we can kind of check it out. Um, so I'm going to make this little plot here, and we're going to talk about it. So here's Texas in orange and Oklahoma in blue. Um, what we're going to do is we're going to pretend, again, none of this is real, but I'm going to take these few counties and these few counties right on the border of either state and say that, you know what, this Texas border is a little bit arbitrary. It's kind of, these two places, these counties on either side of the border kind of face the same climate. They kind of face the same economic opportunity, though, Texas is a little bit different. Probably similar crime rates, probably, they're just all different sorts of things they're facing very similar stuff because they're really related geographically. Versus if I were to take somewhere, a place like El Paso or somewhere, I think over here is Houston. If I were to take like those counties and then compare them to Oklahoma, places in Oklahoma, well, these are just different places. It's not necessarily fair to compare places in West Texas or something like this to northeastern Oklahoma. These are too far away. They're not dealing with the same climate, not dealing with the same um, other other things. Whereas right on the border here is a pretty random divide, I guess you could say. And the idea is that we collect some data from here, we collect some data from right below the line, and then we're going to compare these two states over time, or these counties over time. So I'm going to create some data, but I'm not going to show you how I'm creating the data so we can, because if you see it, then you kind of know what the parameters should look like. So I'm just going to run this. I guess technically it'll be here, but I'm just going to hit enter a bunch of times just so we can think about it together. So I made this plot. Fantastic. I can make it a little smaller. And I'm going to open up crime and just take a look at it. So when I open up the data set, I have the state. So this one looks like Texas. I have the year. I have some level of unemployment. And again, this is all made up data, entirely made up setting. I have this variable called crime, which is some crime rate. And I have county. This one says Texas 1. If we keep going, we'll end up seeing Texas 2. I just labeled 10 places for Texas, or maybe even 20 places for Texas. Oh, no, Texas 10 and then Oklahoma 11. So this is the count, which county it is. Again, doesn't, not based on anything, just for an example. So we have years. So if suppose I wanted to just kind of explore this, I can make a table of the state. So here I have 200 observations from Oklahoma, 200 observations from Texas. Maybe I wanted to do year. I have 20 observations for 2001, 2002, 2020, right? So it goes on and on and on. And then unemployment, maybe I wanted to plot table of unemployment. So crime, employment. It's really, really tough to see anything here because it's just a solid black mass. But rather what I can do instead is I can just round it. So I'm just going to round it to the nearest maybe 10th. So now it looks something like this. I guess it looks somewhat of a normal distribution. Again, there's only 200 observations, so it's not too much. And then maybe I'll plot crime, see what that looks like. Okay. Now finally, maybe I want to make some XY plots, so some scatter plots. So if I want to do crime, unemployment, and crime, we see a pretty nice relationship there. So clearly unemployment is going to be an important indicator. It looks like as I increase unemployment, my crime is going to be increasing. That's a pretty standard finding. Though, so we'll use this as a control, but now we're going to talk about the actual differences and differences estimation part of this. So I created the data, and now we're going to start looking at some aggregates. So the first thing I'm going to do is I'm just going to aggregate crime by state. So I'm using the aggregate function. I'm going to aggregate the crime by this list, which is just going to be a state. And I'm going to use the function called mean. So I run this, and I'm going to print it. And here's my group. So Oklahoma, and here's my average crime rate across all of Oklahoma, across all of these years. Average crime rate is 20. Average crime rate for Texas is 14. So we see that, okay, Texas has a lower crime rate. So maybe the implementation of this death penalty decreased crime in Texas relative to Oklahoma. But maybe Texas just always has a lower crime rate, right? We can't really say anything. This is not really evidence of anything. It could be the evidence of maybe the death penalty is having some massive effect, or maybe it's just the case that Texas always has a lower crime rate. Well, if we can then, if you want to look at it, okay, let's look at it by time. So if I look at it by time, I can look at what's the crime rate pre-death penalty, so right here, 19, and post-death penalty. So it looks like 14. So maybe after the death penalty, maybe there's less crime. But it could just be the case that afterwards, just crime is going down in general. Maybe, because of new economic incentives around that area, there's just less crime in general. We really can't tell the part of these two things. Rather, what we have to do is we have to look at both of these things, right? Texas before and after death penalty, and Oklahoma before and after death penalty. So if we do this, if you remember, the differences and differences thing is going to be your treated post-treatment minus your treated pre-treatment. So that's going to be Texas post-death penalty, so this guy right here, minus pre-death penalty. That's going to be about -6. I'll write it right here, the little semicolon. And this one is going to be post minus pre for Oklahoma. It's going to be about -5. So the idea is like, okay, this is a small, the difference in these two things is now going to be -1. But is this -1 statistically significant? Is it large? I mean, as a percentage, it's not very large. If we're thinking about the average here, I think it's about, say, 16. 1 divided by 16, 6%. I mean, it's kind of small. So what we want to do is we want to kind of investigate it using differences and differences, using a regression framework. So the first thing we're going to do is we're going to plot all of the data. Let me just hide this really quick. Okay, so the first thing I'm going to do, I'm just going to plot the data. So here we can now see that there is a clear change in 2012 when I'm pretending the death penalty came into play. So here I'm seeing that the average crime rate is hovering around 20 maybe, and then down here is hovering about 15. So again, it's going to be that -5 that we were kind of looking at before. But now we want to see, okay, well, is there a difference in Texas versus Oklahoma? So I'm going to stick with orange here. This is actually orange. So I plot this. Right now I plotted nothing. I used type equals n, which plots nothing. So then I can plot each county's time series. So if I run this, we can see here all the counties in Oklahoma and their crime rates. And we can see that there's a decrease, a clear decrease. We can see that in Texas, it's always lower. And then all of a sudden there's a clear decrease. So we see the same pattern for both of these places. So the question is, well, was there a true effect if both of these places decreased, right? This is what we are going to call the control group or the counterfactual, right? So what would have happened if there wasn't a death penalty implemented? And that's what we're interested in. We're interested in using Oklahoma as a control group or a counterfactual that's going to give us the treatment effect. So now what I'm going to do is I'm just going to plot averages. So now I'm going from plotting all the data, showing you all the data, plotting or just looking at averages, and now kind of doing them both together. So the first thing I'm going to do is I'm just going to plot, again, nothing, just an open screen here for us. And the first thing I'm going to do is I'm going to plot both the Texas time series and the Oklahoma time series. So if we plot this, what I've done is I've just taken the average at each point of all the counties. So here's the average crime rate for Oklahoma before and after the death penalty was implemented. So we see a decrease, and that could be for any number of reasons. Could be for economic reasons, could be maybe spillovers, who knows. Now we see a decrease here for Texas as well. So it's kind of chugging along, and then the death penalty gets implemented and it decreases as well and stays pretty steady here. So now we're interested, okay, are these two things the same, or are they or is this difference kind of the same, or is there a true treatment effect? So what we're going to do is we're going to plot the average across that time period. So this is going to be that if we look at the aggregates, that's going to be this 22. It's going to be right here. Now what we're going to do is I'm going to plot the Texas version. So if I plot that, that's going to be plotting the pre-death penalty Texas, so 16. And then we're going to plot the post-treatments. So here's the average. It decreases, goes to this average. Here's the Texas average, and it decreases. So what we're interested in is, did Texas decrease or change more than Oklahoma did? So what we're going to do, first thing we're going to estimate is the change in Oklahoma. That's going to be the solid blue line right here from the 22 down to the 17.8. So what we're going to do is, if this is the counterfactual, and this is just the effect of time, because this isn't really a treated place, right? It's just kind of happening. If that's the case, well, let's take this blue line and let's put it right here and see how it stacks up to the change in Texas. So now we can see, okay, well, here's what the change for Texas. So here's what our counterfactual would have predicted for Texas if the same change happened for Oklahoma. So we would see that, we should expect a crime rate to be right around here if the death penalty hadn't been implemented, right? Because this is not affected by the death penalty. This is just an effect that goes down and whatever. This one is going to go down, but there's still this extra little piece right here. And this right here is going to be what we call the causal effect, or the differences in differences, right? This is what we're trying to isolate. This is what we're trying to estimate. Is this red line statistically different from zero? Is this effect different from just chance or nothing, right? We want to show if this is statistically significant, then we can say, hey, the death penalty diminishes crime rate. And we can say by how much, so if, the average crime, is that 6% really kind of meaningful? Is that something that we care about as policymakers or as economists? So we're going to do some analysis. So I'm going to create a variable called DP, which is death penalty, for if the year is greater than or equal to 2012. So that's going to be the interaction that's going to capture all of this decrease right here. Okay. So for regression 1 and regression 2, we're going to just look at the unemployment, the effect of unemployment on crime. Again, unemployment has nothing to do with this diff and diff, but it's a control variable, and it could alter our results. So if I run these two regressions, we see that unemployment seems to react more to, this is Texas, this is not Texas. See, we can see here, this is not Texas. So for Texas, unemployment, a 1 unit increase in unemployment will increase the crime rate by 1.6, whereas a 1 unit increase for Oklahoma will only increase by 0.8. If I run 3 and 4, I'm now controlling for unemployment and the death penalty together. So I'm going to get rid of this one. And what we see here, again, we're separating this by Texas and not Texas. So the death penalty here seems to decrease in Texas by 5 and decrease here by 3. So what we're interested in is the difference between these two things. So regression 5 is going to be unemployment and death penalty for each place. So let me run regression 5. Here we see unemployment is positively correlated with crime, sure. And we see death penalty decreases the overall crime rate, or that time period of the death penalty being implemented in wherever is going to decrease the crime rate by 2.5. However, this is just the time period effect. This is biased. This is not the true causal impact of the death penalty in Texas. So the next thing we're going to do is we're going to look at regression 6, which is going to give us the impact. So we're going to control for unemployment, we're going to control for the death penalty, and we're going to control for the state itself. So whether or not this is Texas. So if I run this one, we can now see that unemployment increases crime by 0.4. The death penalty, the time period that is the death penalty, decreased crime by 4 units. And Texas, on average, has 5 units less of crime. So crime per 100,000, per 10,000, overall crime, whatever this is measured in, it decreases crime by 5 units. Just being in Texas, because for some reason, Texas crime rates are just lower to begin with. And then finally, what we're going to do is we're going to run an interaction term. So we're going to use this little multiplication sign. And if we run this, this is going to be our differences and differences. Column 3 is a differences and differences specification. So what this is saying is that unemployment increases crime rate by 0.4. Great. This is just a control variable. Now, Texas, just on average, has less crime than Oklahoma. It has -4. So it has 4 units less of crime than Oklahoma, just by chance. It's just Texas and there's different laws. Maybe it's a little bit hotter in Texas. Who knows? It's just different. Then for our death penalty, that time period is going to decrease our crime rates on average by 3. Just because of that time period, there's stuff that's going on that's decreasing by 3. But the true effect of our death penalty, it's going to be how much more did the death penalty time period change in Texas, in the treated area, versus the not treated area. And that's going to be our interaction term. That's going to be our -2. So this right here, the length of this line, is going to be -2. And that's telling us that the causal impact, the causal effect of this effect is going to be 2 units of crime. That's what the death penalty contributes to society, and we should price it, or however we have to, think about it. We can now talk about death penalty with like actual numbers. Maybe two is a lot, maybe two is only a little bit, right? And we have to kind of think about it as a society. So then the next thing we could do is talk about heteroskedasticity. So we can use the same exact stuff that we were using before. So if I use, I'll just load in these libraries. Maybe I'm concerned that there's some sort of heteroskedasticity happening. I can do co-op test, reg 7. We can take a look at this one, and we see, yeah, there's a little bit of heteroskedasticity. In these two cases, it actually decreased the standard error, but in these cases, it increased it. Or this one, it actually decreased, and this one, it increased. Very, very marginally. This one actually decreased as well. So this one is actually a more true picture, or a better picture of the true effect and the analysis and stuff like this. Though everything's always significant, but this one is a little bit better. And then that's everything I have to say for differences and differences. I'm just going to leave this up on the screen really quickly. But that's going to be it for this module. And then email me if you have any questions, and I guess start working on your projects.